For today's lab, we're going to be going over good lab practices. So these are things just to make sure that you're safe and that we're handling the samples and everything properly. A lot of this will have been covered in the university training. We do have some lab-specific items that I just want to go over real quick, just so that you know what to expect when you're working here in the EAL or in any lab. So first off, the best way to keep you safe is to prevent exposure to any of these harmful chemicals. So the way we do that is PPE, right? So we're wearing our lab coat, we're wearing gloves, we also have goggles if you need them for the specific things, but generally out here in the lab you won't need protective eyewear. Also long pants and closed-toed shoes. And that will just help make it so that you don't get exposed to anything that can hurt you. If for some reason exposure does happen, we have a couple things that you can use to contain the situation. So we've got here our eye wash station. So you're going to just pull this down. Water will start shooting out of the jets. Water will also start coming out this hole at the bottom into the drain. If you need to use the shower, you can pull down this handle and then close the curtains and remove any clothing that you're wearing. So that's how and where the eye wash and shower are. We also have first aid kits. They're right here. Band-aids, burn ointment, things like that. We also have a fire extinguisher that is in the wall over here, so that if there's a fire, you can use that. Remember, pull the pin, aim at the base of the fire, squeeze the handle, and sweep to put out any fires. Hopefully you won't need to use any of those things, but remember where they are so that if in an emergency you need them, you can access them quickly and efficiently. If you do have an accident or an injury, first step is to contain the situation, make sure that that person has received first aid. And then if you need to call the risk management or our 911, please do so. We've got the phones here. The risk management phone number is on the phone list behind it. And then once you've done that, let me know, or let your lab manager know, so that they can report the injury and get the paperwork taken care of. Here's where we store most of our chemicals for the EAL. We've got different things on all kinds of shelves, but if you're looking for just the pure chemicals that are solids, this is where we keep them. They're separated by their hazards. So the green means that there's no major hazard for the chemical. We also down here have the larger containers that are no major hazard. And then the different colors indicate different hazards. So yellow is the reactive or oxidizing chemicals. Blue is toxic or deadly if ingested. And then we have white, which are corrosive. We don't want to mix up the chemicals on the shelf. Generally, they're in alphabetical order, but if you take a chemical off this shelf, make sure you put it back in the right place. So these different hazards help you know how to handle the chemical and whether it's a hazardous waste stream or not. So if you are mixing together something from this yellow, the blue, or the white, that does mean that it is now a hazardous material and it needs to be disposed of properly when you're done with it. So it would go in the hazardous waste container. That container is around the corner here. When you're done with your procedure, you're going to put it into one of these containers. And we have to report everything that goes into these containers. So make sure that you write down what you're adding into the container so that when we send the file to risk management to have them come pick up the container, we can report what chemicals were in the container. And always make sure that this waste container number matches the number on the container. Sometimes that number is facing the other way, but if you turn it around, you can see that the number matches here. Also, don't fill above this line. When it gets to the line, let me or whoever is in charge of waste disposal know so that they can schedule a pickup. When you're mixing different chemicals together, you're going to use some of this glassware, or some of it is plastic as well. So I'm going to go over how to correctly use glassware. First thing before you add anything to a container is to make sure that it's labeled. You need what you're putting into the container. You should have a date and your initials so that if we have any questions about what it is or what happened when it was made, we can ask you about it. If it is hazardous, it should have those hazard markings on there as well. These have all been cleaned. Generally in this lab, we use acid washing to clean our glassware. That just helps remove any of the contamination from the different nutrients or metals, those kinds of things. For the most part, we use hydrochloric acid when we're washing, but we do measure chloride in some of our tests. So we have a specific shelf here for anything that we're running chlorides with. These have been washed in nitric acid. We want to make sure that these don't get mixed up so that we don't have chloride contamination when we're running the chloride tests. So there's a lot of different kinds of glassware. I'm going to go over them sort of from the least accurate to the most accurate. Our first one here is that we have test tubes. We have different sizes of test tubes. We have small test tubes and we have large test tubes. And these don't really have any markings on them to know how full the container is. These are just good for mixing and for holding samples. So you might use a pipette or some other container to add sample and liquid into these, mix it, and then use it to go on one of the instruments, for example. With all these little tiny tubes, we'll fill out a sheet that will record what sample is where, so that you don't have to label each one of these individually. The next one that we have are beakers. These have markings on them, but they're not very accurate and they're hard to see where the line is with the liquid. So again, these are mostly just for holding other liquids that you've used something else to measure them into, or if you need to pipette some acid, you could pour acid into this and then pipette from this beaker. Those are beakers. We also have plastic beakers as well. And then we have an Erlenmeyer flask. The way I remember this is that it starts with E, and the sigma Greek letter looks like the letter E, and it's got that curve like the Greek letter sigma. I don't know, that's just how I remember it. Erlenmeyer flasks, a little more accurate, but for the most part, we don't use these to measure, but we would use these for mixing. They're nice because they've got that narrow neck, so you don't get splashing outside of the beaker. Next up, we have centrifuge tubes. We've got two kinds of centrifuge tubes, some that have this skirt on the bottom. That's nice because then you can set it on the counter and it will stand by itself. Again, it has these markings so you can see how much liquid you've added to the container. Other ones don't have this skirt, so you'll have to use a rack when you're running a bunch of those samples. So these are the example of a regular centrifuge tube. These are good because you can put them, as the name implies, in a centrifuge, and it will spin down the solids so that you can pour the top liquid off. All right, our next up is a volumetric flask. We've got a bunch of different sizes of volumetric flask, starting here at 5 milliliters, and then going up, our largest is a 2 liter. And so that just depends on the size of the volume of liquid that the solution you're making. Now each of these has a faint line on it, and that line indicates where the bottom of the meniscus should be when the solution is finished. And that is temperature dependent, so these are all at 20 degrees. It says TC here, that means it's to contain 500 milliliters at 20 degrees Celsius. The different glassware have different grades, so the most accurate ones are an A grade glassware. These are some of the most accurate glassware that we have in this lab, so things where you need to be really precise, like making calibration standards, these are the glassware that you should use for those. And then another really accurate and precise type of glassware plastic that we have are the graduated cylinders. Again, they have the markings on them. The difference between this and the volumetric flask is that these are designed to deliver, so it says TD here. So instead of containing the volume that's on the line, it will deliver that volume. So you can use this to pour into something else, but you wouldn't make a a solution inside a graduated cylinder. Some of the most accurate ways that we have to measure things here in the lab are using a pipette and a balance or a scale. So I'm going to show you how to use a pipette. We have different sizes of pipettes that can pipette different amounts of liquids. And this one does 100 to 1,000 microliters or 1 milliliter. And this one does 1 to 5 milliliters. And then we also have a 1 to 10 milliliter pipette. You set the amount that a pipette will draw up by turning the knob here on the top. So if you wanted to set this to 1 milliliter, you would just spin it until it reads 1. And then in order to suck up the liquid that you're trying to pipette, you would get a pipette tip. We store those in a drawer here. The different sizes go to the different pipettes. They'll only fit the correct size. So the smaller ones are for the smallest, and then the largest for the 10 mil pipettes. We also have filter pipette tips. These are disposable, whereas the rest of them that we use are reusable. So these will go to the sink to get acid washed and reused. But these filter ones, they have a little filter in the tip so that nothing can contaminate the pipette. And so those will be thrown away once they're used once. So in order to suck up, you'll use the pipette tip. You'll put it into the liquid. I'll use this as an example. And you'll hold it straight up and down and avoid the bottom. Put it into the liquid and slowly and evenly release, and then you've sucked up the liquid. To push the liquid out, you're going to, at a little bit of an angle to the wall, release, push down, and then go to the second stop, and then release. And that's how you expel liquid from the pipette. And then when you're done, you remove the tip, and you can throw it away or put it in the sink. Something about the pipette is that you always want to be holding it up and down. If you need to set it down, make sure that you remove the tip first. That will make sure that none of the liquid flows into the pipetter or into the filter that is in some of the pipettes. When those get dirty, it will contaminate the other samples that you're pipetting into, and it can ruin the pipette. So we just want to make sure that we take the tip off before we set it down, or we can come hang it back on the stand here. Periodically while you're pipetting, make sure to check this number to make sure that it hasn't drifted. Sometimes this knob will turn a little bit from where you're holding it. So just check it to make sure that when you end, it's at the same number. And if you aren't sure if it's dispensing the correct amount, you can use a scale to pipette up the amount, and the scale should go down by the number of grams as the number of milliliters that you've pipetted. And if that number isn't where you expect it to be, that means that the pipette might need to be recalibrated, and we'll send it to the science support shop to be recalibrated. So these balances, we have a number of different balances throughout the lab. They have different levels of precision, so that's the number of decimal points that you can measure to. They also have different amount of weights that they can measure. Some of them, if you put too much weight on, the numbers will go away. That just means you need to use one of the bigger scales. So a couple of things about these scales, they should stay where they are. Don't move them around. That can alter the calibration. Also, they should all be level. So there's an air bubble on the back or on the side. You want to make sure that the air bubble is in the center of the ring, and that means that the scale is level and that it's okay to use. If you move them around, sometimes that leveling will get off, and so we'll have to fix that. Another thing to be aware of is air draft. So as you move by, blowing air will make the numbers change on the scale. So if you need to measure something accurately, you can use this scale that has doors so that when you weigh, you can close the doors, and then you won't have as much air drafts making the number bounce around. You can tare, which will remove the amount, and then you can weigh your sample or the chemical into the container. Make sure that these are clean. If you do spill inside of them, you can use one of the paint brushes to brush it off, and we'll just make sure that that way we're not getting any contamination, and that the number of the weight being measured by the scale isn't being biased in any way. I'm going to demonstrate real quick an example of how you would weigh out something for making a reagent or a calibration standard, something like that. So to start with, we're going to label our glassware. So we're making 0.01 normal NaCl, so I'm going to write that. 1 normal NaCl. I'll put today's date. And my initials. All right, so that's ready. We're going to weigh out our sodium chloride. So we want to make sure that this is the correct purity of sodium chloride. So we've got certified ACS. That means that it's clean, and this says what the impurities are. So we're using a lab grade certified ACS sodium chloride here. We also want to make sure that it hasn't absorbed any moisture. We're going to be weighing it out really precisely. If it's sucked up moisture from the atmosphere, that's going to alter how much of the chemical we're getting out when we weigh it out. So if it's an old container, you need to make sure that you desiccate it first to make sure it's dried down, so that you're only weighing out the chemical, not the chemical plus the water that's absorbed in. So the scale has been calibrated. We've labeled our container. We're going to weigh out our chemical now. So we're going to weigh out 0.0584 grams. So I'm going to put in my weigh boat and then tare the scale. I'm going to grab sodium chloride and a spoonula. It's a cross between a spatula and a spoon. It's a spoonula. 0.0584 is a tiny amount, so we're going to just add a little bit more. That was too much. So we're going to scrape some out. And try again. Almost there. I think as close as we're going to get with this scale. So now we want to make sure that as we add this to our container, that everything that's in this weigh boat gets transferred in. If we leave any behind, then our measurement won't be as accurate. You can use a funnel if you need, but you can roll up the weigh boat and just pour into your volumetric flask. And then what you're going to do is get a squeeze bottle and rinse any chemical that might be left behind on your weigh boat or your weigh paper into the flask. And that way we've gotten 100% of the chemical. We call that a quantitative transfer. So then we can wash down the sides, get all the liquid, all the chemical from the sides down into the bottom. And then we're going to fill this up with NanoPure or DI, whatever the instructions call for. We're going to fill it part way. And then use a squeeze bottle to top off so that the meniscus, the bottom of the meniscus, is at that line on the neck of the bottle. So that's the right amount. We're going to cap it, make sure that it's mixed up really well. Sometimes things don't dissolve really well, and so you'll want to add a little bit of liquid and then mix it before you fill to volume. And so then you've got your solution made, and that's ready to be used.